Hello, 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 hello. Good evening, everyone. Good evening, good day. How are you guys doing? And we're having a different video today. Are you guys excited? Okay, so for today, Mr. Sender, when wink wink, send us activities. We have a lot of questions here concerning about reactions, redox. There seems to be some like ideas here, some biology, uh, conversion, dimensional analysis, stoichiometric reaction. So there's a lot here. This seems to be like basic chemistry. Okay. Uh, so for today, we're gonna be answering this activity. Seems like a quiz. There's a lot of questions here. I hope you guys are excited. Let's start now. Right? Let's start now. Let's get to it. Let's go. Anyways, uh, okay. Let's start with number one, multiple choice. I'm just gonna like do a red ball pen here. Branch of chemistry concerned with the electricity and chemical change. Electrochemistry. Right? Nuclear chemistry is nuclear, radioactive materials. Chemical engineering is such a general topic. Redox reaction is about reduction in oxidation reaction to which under electrochemistry. And it says branch of chemistry. So it must be chemistry. Okay, the process of an ion increasing in number of electron. The process of an ion, so let's say an ion, let's say H plus, increasing in number of electrons. So when we add electron, oh, okay. So meaning you lose or you add a negative side. So it's gonna be like reduction. Okay. There's no such thing as electrolyzation. See, it's all red. So it means there's no such thing as that word. Oxidation is when you increase ions. Electron addition, I mean, it's basically electron addition, but it's not a process, you know. You're adding electron. Two electron can probably be called electron addition. No? Right? So the process is reduction. Okay? The sum of oxidation state of each element in neutral compound is, so basically this is like a fact or a knowledge. Okay, so whenever you find those like neutral compound, O2, N2, you know, carbon solid, okay, they're all charge 0. Okay, and you know, neutral. So meaning the charge is 0. Neutral. Right? Neutral. It says 0. So if it's a positive ion compound, there should be a higher oxidation state. Okay. Is my voice low? I think my voice is low. Okay, let me just drink some water. Anything that occupies space and mass matter. Okay. Matter. Okay. Liquid changes shapes according to space and mass. No, according to the container. Volume doesn't have necessarily mass. Gas don't have mass. They have mass, but they have substance, but they don't have like a weight, right? Solid and liquid is under matter. So they have space and mass. Okay? It is the capacity to work, energy. Capacity to do work. In the reaction below, KBr is plus AgNO3, KNO3, AgBr, which is the reactant. Obviously, this left part. This is reactant. Okay, and product. Okay, so basically, well, I'm sorry for saying obviously, but in a reaction, in a equilibrium reaction, the left goes to the right, right? So what happens to the left, okay, becomes the right. The right is the product, the left is the reactant, okay? So which is the reactant? KBr, probably. Silver, there's no silver in this equation. Aqueous is a phase. KNO3 is in the right side, so it's a product. So, KBr. On number 6, which is the product? KNO3. Okay, KNO3 is the product. It's on the right side. Okay, that's it. The mathematical equation to which relates the standard cell potential to... Oh, okay. So, standard cell potential, there's only one guy. Avogadro is about atoms. Avogadro say that, oh, blah, 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 blah. So, Avogadro has Avogadro's constant that says that for each 6 point... Oh, there's a calculator here. Constant. Is that 23? No, that's not 23. Constant. Oh no, I don't remember. Oh, this one. Okay, 6 point. I think that's it. 6.020. Oh my god. 2214 times 10 to the 23. There is like atoms per molecule. Gibbs equation is about energy. Gibbs equation is about energy. Gibbs free energy. So it's not about cell potential. Redox equation is something about reactions of ions, right? Redox reaction, reduction and oxidation reaction. So it's not an equation. Okay? It's not redox equation. There's no such thing as redox equation. It should be redox reaction. None of these. They're talking about when you say cell potential and actual cell potential, that's Nernst's equation. Nernst's equation, okay? So he's the main guy concerning about cell potential. The only guy there. Nernst's equation. Let's start with the bonus. With the multiple choice. Let's finish the multiple choice first. As you're checking out a reaction tank in a chemical factory. Ooh, chemical factory. Ooh, I'm imagining I'm in a factory. You notice that the moisture is condensing beside the tank. So it's probably cold. There are no the reaction in the tank is endothermic. No. Wait. The tank is probably cold. That's why it's condensing, right? So there are no reaction. It's a reaction. It's a reaction tank. There should be a reaction. It is raining inside the factory. What? What? Well, very wrong. So endothermic is happening and it is exothermic. Okay. So if it's very cold, meaning it's the reaction is absorbing heat. Okay? Okay, if it's very cold outside, means in the reaction is absorbing heat, taking out the heat from the air, condensing the air because it's getting lower. Okay, so endothermic is absorbing heat. So it's an endothermic reaction, letter A. Okay, letter A. Okay, so we must analyze where the heat is going. Okay, so because the water is condensing and turning, the vapor in the air is condensing, meaning the container is cold, it means it's absorbing heat. Now the heat is going inside, or it's trying to absorb heat, but it's still cold, right? The work is done on the surroundings for an expansion process. So meaning there's like release of energy. It expanded, so release of energy. And it is done on the system for a compression process. For this statement, choose the most correct answer. The work is done on the surroundings for... Yes. When let's say a balloon expand. Let's say a balloon expand. No. What expands? Let's say a piston. Let's say a piston expands or moves. Right? A piston moves. The piston is pushing something. It's giving work. Okay? Okay? And it is done on the system for a compression process. If you like squeeze a balloon or a ball, you are squeezing the ball, so there's work being done into the ball. So statement is true. Okay? Statement is true. Okay? Natural polymer comprising of 9 amino acids. Okay? That is capsaicin is I don't know if it's coffee or chili. I don't know. Do you guys know? I think capsaicin is chili. What's coffee? Caffeine? I don't know. So capsaicin is chili or coffee. I don't know. So I don't know coffee. Probably caffeine is for coffee. No, but I think caffeine is another. Then what's nicotine? I don't know. Oxytocin is for love. Okay, I see the love here. Oxytocin is for love. Adrenaline is fight or flight. Like, it's the reaction for, oh, I must survive. I must run. Endorphin is something about male or female. Endosterone and testosterone. I don't know. So, and whenever I see endor something, I know that it's like estrogen, estrogen or something. That's probably my guess, right? So I know it's oxytocin, right? Oxytocin. I know it's oxytocin. Okay, that's the answers. And yeah, if ever there's a wrong answer, I'll post another one. But if there's no additional video, I'm assuming that's true. I'm assuming that's true. Which, trust me, it's true. Trust me, it's the answer. Okay? 10 kilometers. I'm so confident. I'm answering this today. So whenever I do this kind of video, like doing solving answers for senders, this is the answers that I believe it's true. Okay, and it is true or it is correct in my knowledge. Okay, but if you guys have any problem with that, or do you not a problem, but if you guys have, I could be wrong, right? But if you guys have like a question, or probably, hey Chappy, you're wrong, this is the answer, I might be wrong, I don't know. If you guys have the correct answer, why not just tell me in the comments below, guys. And if you guys want a chance for me to be wrong, please like and subscribe. Okay, thank you so much. Anyways, let's solve 10 kilometers to nanometers. Let's convert first, or let's know first that 10 kilometers is 1,000 meters, right? And per 1 kilometer. And nanometer is such a small number. Okay? So 1 meter is nano. So there's like for prefix, milli for millimeter, millipede, right? Centi, centi. Micro for 10 to the negative 3, 10 to the negative 6, and 10 to the negative 9 for nano. Microbiology. So for smaller than that, nanotechnology. 10 to the 9 nanometer. Okay? So your 10 kilometer could be 10 times, we're having I'm just gonna try to squeeze all the answers here. 10 times 10 to the 12 nanometer. Okay. Okay, Fahrenheit. I know Fahrenheit is a bigger number, bigger temperature. So, I'm gonna multiply Celsius to 9 divided by 5 plus 32 is 32 times 9 is... I don't want to do math. Okay, I don't want to do math. Okay, 320 minus 32 is 290, 288. 288 divided by 5 plus 30. I'm gonna use a calculator. Okay, calculator is allowed in this, probably, in this exam or activity. 9 divided by 5. Okay, Ah, 32 times 9 divided by 5. 57.6 plus 32. 89.6. Right? 89.6. Degrees Fahrenheit. Don't forget the unit, okay? If you guys, don't believe my formula, we could probably use conversion. 39. I think it's like, wait, it's not 39. 26. Ooh. Ooh, I don't know what conversion it is. Oh, we need some help. Okay? 36. Ooh. 35. Ooh. 34. Oh my god, I don't know what conversion it is. Ooh. 32. 16. I don't know what conversion it is. 24. Conversion 30. Conversion 0. Imagine if it's 06. Imagine if it could it be 14? Conversion 30. 33. Conversion 40. Or maybe it's like 8. Oh, I'm sorry guys. I don't know. I don't remember. I don't remember the conversion. Well, I don't have the back of the calculator. To be fair, I don't have the back of the calculator here. So, give me some slack. Give me some. Okay. I know that's the formula. Okay, that's the formula. Okay, you make it bigger. It should be bigger. Ooh, ooh, ouch. Okay, I hate that. Okay, 30. Which one? 26. Let's do 26. I don't know. I give up. I don't know the conversion. Okay. 2 gallons to meter cube. So 2 gallons. Okay. Okay. So gallon. 1 gallon is 3.785 liters. And 1,000 liters is 1 meter cube. Okay. So the answer to that is 2 times 3.785 times 1 divided by 1,000. 7.57 times 10 to the negative 3 meter cube. Okay, that is the converted. 32 degrees. Oh, guys, I didn't know the conversion. 5 plus 32 is equal to 89.6 degrees Fahrenheit. I think that should be the answer. 1 inch to meter cube. Well, I know that 1 inch, that's 1 inch cube, right? So 1 inch cube, let's say, I know that I know that 1 inch is longer. I know that 1 inch is longer. So 2.54 centimeter or 0.0254. Right? Let me. Ooh. 2.54 times 2.54 times 12. 30.48. Okay. Divided by 100. 0.30 divided by 12. 0.0254. Okay, okay, so 0.0254 meter. Okay. So 1 inch is 0.0254 meter cube. Basically, we just cube it. Right? Cube. Okay, 0.0254 cube is 1.63387 1.6387 times 10 to the negative 5 meter cube. Okay, that is now the answer to that. Is that... Alright, nice. Okay. Alright, that's conversion. Number 6, 8 kilogram to pound mass. Oh, come on. 8 kilogram. I know that whenever I check the weight, I know whenever I check the weight, there's always like 180 pounds. That's not my real weight though. I'm sorry, that's not my real weight though. But I know that like it's for 180 weights, that's like 80 something kilo. So meaning the conversion is for every 1 kilogram, that's 2.205 pound. There's more pounds, or the number value is much greater when using pound. Okay, so that's like 8 times 2.205, 17.64 pound mass. Okay, that's the answer to number 6. Okay, alright, number 7. Ooh, I'm gonna continue to number 8. Number 8 is much faster. Then we'll go back to number 7. Okay, 4 meter per second to kilometers per hour. No, so let's convert meter first. 1 meter or 1,000 meter is 1 kilometer. Right? Then 3,600 seconds is 1 hour. So what's that like? 4 times 3.6, that's 12, 14.4 something. 4 times 3,600 divided by 1,000. 14.4. No, let's go. 14.4. Cancel seconds. Okay, let's do it. Right? Cancel seconds, cancel meter, and what's left is 14.4 kilometer per hour. That's the answer. Okay? Okay, number 7. Are you guys seeing my solutions? I guess I'm in the corner from last video. Okay. Okay. 15 pound force. Oh, that's a per inch squared. Right? So this is force, a unit of Newton. Right? And pound force is basically it's a unit of Newton. So before we convert that, okay, what do we have on the opposite side? Okay, kilogram, kilometer, minute. Okay, kilogram, kilometer, minute. Okay. So first, pound force is basically pound but in a unit of force. And to convert pound force to pound mass is... Okay. Oh wait, this is PSI, right? Pound force per square inch. That's PSI. So okay, so I'm just gonna let's use 1 pound force per inch squared is 1 PSI, and 14.7 PSI is 101,325 Pascal. Okay, and 1 Pascal is 1 Newton per meter squared. Okay, we're cooking. Okay, 1 Newton is 1 kilogram per kilogram meter per second square. Okay, cancel meter. So we have what answer do we have first? Okay. Okay. 15 times 101,325 divided by 14.7. Okay, 103392.8571. 103392.8571. There's a point here. Right? Okay. So that unit is kilogram per meter second squared. That's the unit. Okay? That's the unit. And we want to convert it to kilometer in minute squared. So 1 meter or 1,000 meter at the top, because the meter is at the bottom, is 1 kilometer. And minute squared, so S is in the bottom, so 60 second over 1 minute squared. Okay? Squared. So that will become our final answer. 103,392.8571 times 1,000 times 60 squared. 3.72, 722 times 10 to the 11. Okay. Oh, I'm gonna have to like move the questions, right? 3.7221 times 10 to the 11 kilogram kilometer per minute squared. Okay? So that's our answer to our, probably that's the most hardest or like the hardest conversion from them. Okay? That's the hardest conversion from them. Aside from that, all the other questions like a freebie, Fahrenheit, come on. We know Fahrenheit. We already like, we already like tackle Fahrenheit, when we're sick, when at home, when we're holding a thermometer. Okay. Okay. So let's continue. How many minutes do we have? 27 minutes. Is this taking long? I'm gonna do it faster. But so far, how many questions do you have? So far, how many questions more do you have? Oh, I think we're halfway there. Okay, I'm gonna go with balancing. I think balancing is more fun. Or it's gonna be like easier, right? Let's go with balancing. Okay, balancing. Let's do this first. So when it comes to balancing, let's do with the uncommon metal first. So there's like 1 here, 2 here. So I'm gonna like make it 2 here. Then carbon. So if there's like 2 carbon here and 2 carbon here, there's like 1 carbon here and there's like 1 carbon here. Oh, that's like okay, that's good balance. Then next is hydrogen. There's like 2 hydrogen here. There's like 2 hydrogen here. That seems good. Alright, for oxygen, there's like 6. 2 times 3. 2 times 3. That's 6. 6 oxygen. Right? This one we have 3 oxygen here. 1 oxygen here and 2 oxygen here. So meaning this is already a balanced reaction. Nice. That went so well. Hey, that went so well. We just multiplied this by 2 and that's like balanced reaction. Hey, that went so well. 2 Na here, right? 2 carbon, 2 carbon, 2 hydrogen, 2 hydrogen. Oh, that went so well. Okay. Okay, that felt so good. Alright. Redox reaction. Oh, redox reaction. So when we're talking about redox reaction, we check the ions first, right? So chromium, the chromium here is, we don't know the chromium, so 2Cr, plus the oxygen is -2 times 7 is equal to the total charge is -2. So that's like -14 is equal to -2. So that's like -2, +14, +12. 2Cr, 2Cr, 2Cr. Chromium is positive 6 here. Okay, so the chromium here is positive 6, while the chromium is positive 3. So our chromium reaction, right, our chromium reaction going to Cr3 plus. If this is positive 6 and this is positive 3, so he probably gained 3 electron. Okay, that's one chromium. Why? That's per chromium. So there's like 2 chromium here. So we're gonna make this 2. And if there's like 3 electron per chromium, that's gonna be like 6 electron. Okay, 6 electron. Okay. Okay, that's how you balance redox reaction. You check the compound, okay? So carbon here, the carbon here is this is the balance for chromium, okay? I'm gonna go with the carbon, okay? CO2. So CO2, that's like carbon plus 2O2 negative 2 is equal to 0 because there's 0 charge here. So that's negative 4 is equal to 0. C is equal to 4. That's the charge there. C2O4 negative 2. This one. Oh, sorry. This one, right? Okay, C2O4 negative 2. C2O4 negative 2. So there's 2 carbon plus 2 times negative 4 times negative 2 because there's like 4 oxygen. Total of negative 2, negative 2, negative 8, negative 2, positive 8, positive 6, 2 carbon, 2 carbon, 2 carbon, C is equal to 3. Meaning, your carbon, C2O4, negative 2, going to CO2, change state. It become 3. It oxidized. So, meaning, it lost an electron, okay? Because this is positive 3, this is positive 4, it oxidized, it lost a negative value. So it lost an electron. But because there's 2 carbon, I'm gonna put this 2 and I'm gonna put this 2 electron. Okay? And in order to balance the 2 reaction, because chromium needs 6 electron, you know, since chromium needs 6 electron and carbon only provides 2 electron, you know, we cannot divide this by 3. We cannot divide chromium by 3, so we're just gonna multiply carbon into 3. So 3 of C2O4 negative 2 going to 6 of CO4. Oh wait, that's it for CO2. Then plus 3 or 6 electron, right? So when we add that, that's gonna become Cr2O7 negative 2 plus 3C2O4 negative 2 plus 2Cr3 plus 6CO2. Okay? 6CO2. That's CO2? That's CO2. Okay? That's not yet a balanced reaction. Okay, now that we have like the balance for electron, we now add hydrogen. Okay, we can now add hydrogen. Okay, so for now, in order to add hydrogen, we're gonna check out the balances. Notice that the total charge for the left side, that's negative 2 here. There's 3 negative 2, that means 3 times negative 2. Negative 2, negative 6. While on the opposite side, the total charge is 2 times 3 plus. So that's positive 6. So this cancel out. The charge here is negative 2. We're gonna add 2 hydrogen plus on the right side. No, not the right side. The left side. 2 hydrogen plus on the left side. So that there's like 2 positive 1. Right? So 2 minus 2 minus 6 is equal to 6. Okay? Oh wait, we're wrong. That's not balanced. So this will become negative 6 and positive 6. So in order to compensate with that, we need more, right? So we need 14. 14H plus. So this becomes, I'm sorry, we make mistakes, but at the end of the day, we need to re-wrong or rewrite our mistake, right? So our 14H plus will provide us 14 positive. So 14 minus 2, that's 12, minus 6, that's positive 6, is equal to the positive 6 of the opposite side. Now, that would balance H plus. We need to balance H plus. There should be like 7 H2O here. Okay, so 7 times 2 H2O, that's H2, that's gonna be like, right, double check, right? Double check. If there's like 14 hydrogen here, there should be like 14 hydrogen of the opposite side, which is, there is 7 H2, that's 14. Then 2 chromium here. 6 carbon. Then there's like 6 carbon on the opposite side. We have 7 oxygen. 3 times 4 is 12 oxygen, so that's 19. Then 6 times 2 is 12 plus 7 oxygen. So that's like 19 is equal to 19 oxygen. Okay? So everything is balanced. This is now our balanced redox reaction for this question. Okay? For this question. Okay? In acidic solution. Okay? This is the balance. Okay? So there's like 2 different balancing. First off, when it's redox. Second, if it's not redox or normal stoichiometric reaction. Okay, so that's good. I'm feeling good about that. How many times? Let me check my RRs. 37 minutes. We took some time. Okay. Okay, let's solve for another one. I think that's very fun. I love balancing. Let's solve for this question. Okay. Okay. Reaction conversion. The Torre. I play some Genshin. This is very fun. The Torre Laboratories Incorporated produces about 600 liters of 1 mole molecules per liter of AgNO3 every month per month. Okay? And it gives it to Aether Incorporated, a waste chemical treatment plant, separated the silver via application of electrolysis. This is the reaction. How much silver is produced per month? How much silver is produced per month? So let's just convert this to mass, right? 600 liters times 1 mole per liter. And we know that silver is 1:1 to silver nitrate. So 1 AgNO3 is 1 silver. It's the reaction. One reaction of silver nitrate produces 1 silver. And in order to get the mass, this is molecules, right? This is molecules. 1 mole of silver is 107.87. Let's check. I'm gonna check. I'm gonna check the periodic table. Molecular weight of silver. 107.87 grams. Okay, the answer will become 600 times 107.87. Okay, 64,722 grams. And that is 600 liters per month. Okay, so they produce about 64,722 grams or 64 kilograms of silver solid. Okay? Okay, that's the answer. Okay. How many liters is needed if Aether Incorporated separated 100 grams? 100 grams? Well, that's ratio and proportion, right? That's ratio and proportion. if 600 liters is to 64,722 grams, then what is 100 gram to X value or to that liter, right? So 100 divided by times 600 divided by 64,722. So basically 0.9270 liters. Okay, that's how many liters in order to produce 100 grams of silver. That's a pretty buff up acid, or sorry, waste. Okay, imagine one molarity, one molecule per liter of silver. That's a lot of waste, you know. Okay. I just checked my sound system. That's number 3. Where's number 1? Why do we have like number 3? Where's number 1? I think that's like number 1. Okay. Oh, I think that's number 1 because we have we have two number 3. Okay, I'm just gonna move this. Oh, there's like more here. I'm just gonna move this lower, right? To where space is. See, I'm solving at the top left corner. Why am I doing that? You know, I'm such a introvert. Alright, let's solve it here. Okay. A cylindrical barrel of oil is required to have a proportion to have 2:1 height. Oh, so there's like a barrel. Well, it's cylindrical to have a proportion of 2:1 height to diameter. Diameter of a circle, right? So this is 1, this is 2. In terms of proportion, diameter and length ratio. If a certain canola oil brand have a density of 0.8 kilogram per liter, how much oil in mass grams do we have given we have 650 liters? Well, we just multiply it, right? Convert per liter times 650 liter, and that's 520 kilogram. Okay? Conversion. Just analysis of unit. Consider a barrels have a diameter of 2.5 feet. How many barrel will 650 liters will fill? Okay, so considering that we have a barrel of 2.5 feet, meaning the height is 2.5. Okay? Or sorry, 5. Right? If that's 1 to 2, diameter is 1. So if this is 2.5, the height must be twice as long, or 5 feet. Right? I'm just gonna convert 5 feet and 2.5 feet into meters, right? To meters. Okay, so feet. Let's convert first to meters. So 1 feet is 12 inch. 1 feet is 12 inch, and 1 inch is 0.3048 meters. Oh wait, that's wrong. Let's directly convert. I'm thinking about the direct conversion, not the indirect. Right? So 5 feet, 1 feet is 0.3048 meters. Right? Times 0.3048 meters, 1 feet. Okay, so convert 5 times 0.3048. 1.524 meters, and the half is, let's divide this to 0.762 meters. Okay, so that's like the specification of our cylinder. To get the volume of a cylinder is pi r square h, or pi 0.762 meters. That's a diameter squared over 4 times height 1.524. Okay. 0.762 squared divided by 4 times pi times pi times 1.524. We divide it by 4 because the formula for diameter is pi d squared over 4h, right? Per volume. 0.6950. 0.6950 meter cube. That's the volume, okay? And again, the volume of a barrel is 600, the volume of the oil is 650 liters. Okay, the volume of the oil. The volume of the barrel is 0.6950 meters. Let's convert. 1 meter cube is 1,000 liters. So that's 695 liters. Okay? 1 barrel. And 1 oil is 650 liters. Meaning, the volume of the barrel is much bigger. Okay? 650 divided by 690. Okay? 0.9420. What is the question? How many barrel will okay? So barrel filled. Okay? 650 divided by 695. Am I correct? Let's use 695. 9353, 0.9353. Okay, not even. Almost 1 barrel, but not even 1 barrel. Okay, not even 1 barrel. Okay, so we're gonna take that as answered. No, almost 1 barrel. Ooh, that's so. How many kilograms is that? How heavy? How heavy is one? This all 520 kilograms. Well, to be fair, 5 feet of a barrel is pretty big. 5 feet of a barrel is pretty big. You know, I'm 5 feet. That's like 1 person. And half a person of 2.5. You know, an average person in the Philippines is probably 5.4. So the barrel is 5 feet and probably half of a person, right? So it should be like half of a person. Right? There we go. Imagine that the length. That's a pretty big barrel, okay? To be fair. Okay? But that's the answer. Okay? Dimensional analysis. Oh, I love this question. They are pretty easy, or just put in the given. Determine the value of G in a proper unit meter kilograms. Okay. So force is 13.34768 Newton. Okay. Let's convert Newton into 1 Newton is kilogram meter per second. So that's already meter kilogram second system is equal to G. M1 is 10 to the 6 grams. I guess that's... let's convert it to kilogram. Right? Times 10 to the 6 grams. 1,000 grams is 1 kilogram. M2 is 5 times 10 to the 9 milligram. Alright. So milligram is 10 to the 3. So that's like 1,000 milligram, 1 gram. Then 1 kilogram, 1,000 gram is 1 kilogram. So we divide it by 1,000 twice. Divided by d squared. So that's like 0.005 meter squared. Okay, remember, 5 millimeter is 1,000. For every millimeter, 1,000 millimeter is 1 meter. Okay, millipede, right? So that's our kilogram second system, meter kilogram second system. Let's determine G, right? So 13.34768. Cancel Newton. Okay, 68. 1 kilogram meter per second squared multiplied to 0.005 meter squared because that's under the denominator. So let's cancel meter one time. Then cancel gram, right? We have kilogram. 10 to the 6 kilogram divided by 1,000 kilogram. Cancel kilogram because this is on the opposite side. We basically transpose both sides. Then 5 times 10 to the 9 milligram. Cancel milligram, cancel gram. We have kilogram also. Divided by 1,000, 1,000 to 1,000. Cancel. Oh wait, there's nothing to cancel. There's nothing to cancel. Kilogram, right? Okay. What else? I think there's nothing else to cancel. We only have mass and distance. So meaning the unit is what's left is meter per kilogram second squared. And we just need to input that to calculator, right? So 13.34768 times 0.005 squared. 10 to the 6 divided by 1,000 multiplied to 5 times to the 9 divided by 1,000 divided by 1,000. 6.67384 7384 times 10 to the negative 11 meter kilogram second. Okay, that's actually that sounds familiar. I think G is the Newton's law of gravitational constant, which is I don't remember 34. No, constant 36. Is that it? No, that's not it. 35. That's gravity. Constant 12. Constant 14. Constant. I don't remember. I actually don't remember. Okay, I'm just gonna go back to you guys once we have like the back of the calculator. But for now, that's the answer. Okay. We already solved 3 problems. Okay. How many hours do we have? We solve it for like 1 hour. We're gonna solve it under 1 hour. Let's concerning that we solve this 8 minutes. Alright. Consider the reaction below. MnO2 for HCl, MnCl2 plus Cl2 2H2O. It seems balanced. 4H, 4H, 4 chlorine, 2 chlorine, 2 chlorine, 1. It seems balanced. If 0.86 mole of MnO2 and 48.2 grams of HCl react, which reagent will use up first? Okay. So, first off, a reaction happens in molecules. So, for every 1 molecule of MnO4, we need 4 molecule of HCl. This one. For every 1 molecule of MnO2, not MnO4, we need 4 molecule of HCl. So, if we have 0.86 molecule of HCl, of NO2, we need 0.86 times 4, 3.44 molecule of HCl. Okay? But we don't have molecule of HCl. We have grams. So we just convert this into molecules by molecular mass. Okay? So HCl 1.007 or 008, some periodic table 008, hydrogen plus 35.45. Wait, let me check on the periodic table. Chlorine, molecular weight, 35.45, sorry. 30.45 Cl. That's grams. No, per molecules. Okay, so one molecule. Okay, how many molecules do we have? 48.2 divided by 1.008 plus 35.45, 1.322 molecules of HCl. So, here's the thing. There's 1.322 molecules of HCl. But theoretically, we need 3.44 molecules of HCl for 0.86 MnO2. Meaning, okay, HCl is lesser. Meaning, HCl will use up more. Therefore, 1.322 is less than 3.44 HCl molecules. Therefore, HCl will be used up first, right? Will be used up first, okay? Or do we call it limiting reagent? How many grams of molecules used? So if the reaction takes place and there's only like 1.3322 molecules of HCl, for every 4 molecules of HCl, we have 1 molecules of Cl2, right? Chlorine 2, right? For every 4 molecules of HCl, we have 1 chlorine molecule. So if we have 1.322 molecules of HCl, and there's like 4 HCl, 1 chlorine, Cl2. What's the question? What unit? Grams. Okay. Let's just convert this to grams. 1 molecule of Cl2 is 35.45 times 2 grams. And that is 322 divided by 4 times 35.45 times 2. 23.4325, 23.4325 grams of Cl2. Okay, that is the answer to letter B. Okay, so far so good. We're answering very diligently. Assuming that the calorimeter takes at 50 calories. Oh, it's a calorimeter problem. It's a heat type problem. Okay, assuming that the calorimeter takes 50 calories per Celsius. 50 calories per Celsius. So, that's probably like, the formula for that is just delta T. Initially, at the 25 Celsius containing water, meaning your calorimeter and your water at T1, T2 is 25 degrees Celsius. T1 is 25 degrees Celsius. Your water, 200 grams. T2 is at 25 degrees Celsius. Okay, your 200 grams of water. And water is, this is in calories. So, 1 calorie per gram, 1 calorie per gram degree Celsius. What will be the fire temperature of the isolated system if a 50 grams of aluminum is at 130 degrees is introduced? So, isolated system, so 0 of total. Then we have like an aluminum of 50 grams with a specific heat of 0.9 joules per gram degree Celsius. I'm gonna convert the joules to like 1 joule, 4.184 joule is 1 calories. Okay, then that aluminum will have like T2 minus 130 degree Celsius. Okay, right? Aluminum is introduced at 130 degrees Celsius. What is now the temperature of water? Okay, we're gonna shift solve that. 0, 50 times x, right? X minus 25 plus 200 times x, right? I'm gonna parenthesis that. Minus 25 times 1 plus 50 times 0.9 divided by 4.184 times x minus 130. Okay, I'm gonna use that I'm gonna do that on a parenthesis so we can solve for x, right? 29.33. I'm gonna double check. 50x minus 25 plus 200. We type a lot of values, and the tendency, if we type a lot of values, we might hit something wrong. 0.9, 4. Okay, alright, that's good. So for x, 29.33008. So meaning T2 is 29. Oh. 29.3309, right? 29.3309 degrees Celsius. Right? That's the final answer. Okay. Number 7. Last question. I hope you guys have enjoyed the lesson and solving. Okay. So that's gonna be it. Okay. If you guys have like any concerns, any raises, feel free to comment on the comment section, And I'm gonna like respond to that. I'm gonna like chat to you guys, and I'm happy. Nasted. What? The grammar of this question is very, very, very nasted. Yeah, very busted. Alright, so in a combustion experiment of methane, that's CH4, O2, 2O2 going to 2H2O plus CO2, right? 10,500 megajoules. That's a lot of heat. Times 10 to the 6 joules. That's mega, right? Heat released. Determine how many grams of methane is combusted if enthalpy of reaction is negative 890.4 kilojoules. Okay? So, the total heat released is 10,500 times 10 to the 6 joules. Right? Joules. Okay? And when we say enthalpy for every 1 molecule, 1 mole of reaction, we have 890.4 kilojoules. Okay? So, we just divide this by 890.4 times 10 to the 3rd joules, or kilojoules is 10 to prefix. Right? I hope you guys know prefix, right? 1 kilometer is 10 cube meter. So obviously 1 kilojoule is 10 cube joule, right? So I just like added 10 cube there. Divided by mole, meaning how many moles do we have? Cancel energy. Move mole at the top. 10,500 times 10 to the 6 divided by 890.4 divided by 10 to the cube. 11,792 11,792.45.4528 molecules. That's how many molecules of methane was combusted to release 10,500 times 10 to the 6 megajoules. And the question is grams, so let's just convert that to methane. 1 carbon is 12 plus 1.008 times 4 hydrogen. 1 carbon, 4 hydrogen. That's grams per molecule. We just convert it to grams, okay? So the whole exam is, or the whole activity is about conversion, right? Majority is just conversion. Okay? Or, well, technically, reaction is a type of conversion, or we're converting one compound to another compound. Right? So that's 189.056.6033 grams, right? Of CH4. Okay, so this is now the answer. Okay. Wow, that's a lot of CH4. And again, that's a lot of heat. 10,500 times 10 to the 6 joules. Okay? Okay, so I hope you guys learned something. It's it's probably gonna be a 1 hour video. Yep, it's a 1 hour and 4 minutes video. I hope you guys learned something, and this is very fun. We basically answered a whole test or a whole exam. And yeah, if you guys like I made something wrong, I could be wrong. I'm not perfect. Feel free to comment, hey Jappy, you did something wrong here, don't harass me, okay? So it's okay to be wrong, okay? But we're trying to learn here. We want to learn, we want to give knowledge, right? So if you guys think I did something wrong, if you guys like have anything to comment on, feel free to comment on the comments, below. And like and subscribe for more videos. And if you guys want to send some of your exams or activities, you can send it here, okay? But we've been busy in real life, so thank you so much, guys. I hope you guys have a good day, and goodbye. Thank you for watching. Bye.